Hello YouTube viewers, welcome to my show Future Friday. In today's episode we're gonna continue our moon discussion and we're gonna today talk about moon rockets. So let's dive right into it. Now first you have to understand all the discussion I'm doing about like where to land on the moon, how to figure out the power problem, all those things are mute unless we can figure out how to actually go there. So when we are talking about rockets, basically we are talking about the core of the mission. Everything revolves around the rocket. So rockets are generally measured in three core criteria. Criteria number one is weight. Everybody is familiar with it, how many tons. Then comes the volume. Now this part is also very critical because we are not sending lead to space or we are not sending building material to space. Basically we are generally sending built material to it, basically a habitat that's already built or habitat that's gonna be unfolding there. But that makes a issue because many times space modules, basically let's say a module that is in International Space Station is 22 ton. Now of course it's a big module. Does it have to be 22 ton? No, they can shrink it down very much, but again it's supposed to carry human inside, so that's why it's so big. So volume also plays a very crucial role. So you can have a scenario where many times people will like, you know what, I can't use your rocket even though it has more capacity, it simply does not have enough volume, aka payload fairing size. So that is also critical. So you measure it in two forms, like how much and how big. Then we come to the launch and launch cost, basically vehicle cost. So let's say SpaceX wants to go, so vehicle cost would be very minimal for them, because even if SpaceX is, let's say, selling you a Falcon 9 for, let's say, $90 million or $100 million in case of an expendable one, they're not going to charge that much to themselves. So the vehicle cost would be low. However, the launch cost would be completely different bargain, because you have to spend fuel, liquid oxygen and kerosene, RP1, they are not cheap. On top of that, you have to think about basically launch pad. Landing pads are free basically for SpaceX because they built it themselves. However, launch pads, they are government owned property, so they have to pay a very hefty amount of sum of money to make sure they retain the access to the launch pad basically. So that is also a considerable expense. On top of that, there are hundreds of red tape that you have to figure out, hundreds of authorities that you have to clear. All of them add up to the cost. So your cost, you can have a scenario where $90 million was just for the rocket and you're like, okay, 90, I'll keep $1 or $2 million extra for the launch system, but it turns out everything else ended up costing more than, like, let's say, twice. It can happen because there is a lot of red tape here. Then we come to the final aspect, basically availability and turnaround. So let's say space shuttle was a reusable craft. It does not mean there was only one spacecraft, basically one space shuttle. They built upwards of 5 to 6. So, and I think final one was not finished properly. So that is availability. How many do you have in case of a failure, in case of an emergency, those sort of things. And then the turnaround aspect. So think of this way, if you are talking about human, you must have a way to quickly remove them from the danger. Basically, if you have to pull them out, you should have the ability to pull them out very quickly, or you have to send help, you should be able to send help as quickly as possible. So turnaround is very critical. Now, what options do we have? Let's say we figured out the rocket. What options do we have? We have two primary options, basically orbital options. Option number one is basically quick and small. This is what Chandrayaan 1, basically India's first moon mission did, is basically they kept increasing the orbit. Now, side effect, this takes very long. Benefit, even a tiny rocket, basically the rocket that if you tried this with Falcon 9, basically Falcon 9 Block 5 can barely send few tons to moon. It can send upwards of twice that if they're using this method. However, this method is not suitable for human passenger. Now, it is more than good enough, like if you are sending, let's say, a solar farm worth of solar cells. Super easy. If you want to send, let's say, anything that is not time critical, let's say habitats, basically you can send them using this method. This method will allow you to send the biggest payload with least amount of fuel. So this is one method. This will be very suitable for cargo. Then we have large, basically quick and small option, basically Saturn V, where you have a gigantic rocket and you just fire it and let it go. You basically can go to the moon upwards of 3 days. So that's very quick. However, it does mean your payload size will be very small. Saturn V, even though it was humongous, even though it had the capacity of 150 tons to low Earth orbit, it could not send basically even 100 ton to moon. So you have to understand. However, if you did that, basically this orbit, you can send that. However, it will take upwards of 2 to 3 months. So these are options. Basically, you will have two different approaches to go to the moon for basically cargo and humans. Of course, you're gonna have emergency cargo that is small enough, let's say medical supplies or whatever is classified emergency enough that you can send it in quickly using this method. But generally, you will rely cargo on this and human in this. Then we come to the, okay, that's going to the moon, how are you going to land it? Now that is very tricky and wasteful, simply because if it had atmosphere, we can simply rely on parachute. It will not require rocket fuel. However, we have to use rocket fuel, because the only way you can land on moon is propulsive landing. Now, can we do propulsive landing? As of now, Dragon basically can do that right now if you wanted to, because you have to understand, this was built from day one to propulsively land. The reason why it was cancelled is simply because NASA did not approve of the idea of having landing legs protrude outside of heat shield. That's the issue with this design. With the heat shield basically has to open up in certain places, basically 4 places, and legs supposed to come out of that. Can it be done? Yeah, easily. The space shuttle had freaking giant landing gear coming out of it. It's doable. It's just that people didn't want that. Basically they wanted heat shield to be one absolute structure with no failure. So if you want to make sure this can this land on the moon, yeah, easily. It has enough fuel, it can do that. That's not an issue. Only problem is they have to basically add legs, and the legs has to be added from the side, otherwise they have to redesign the whole thing. So benefit, we can do that simply because moon has much lower gravity, so weight of this won't be an issue. And not to mention the g-force, there would be very little because of this Draco engines. These engines are very powerful, so they can reduce the delta V, or basically comparable speed to be very low. So legs can be added on, bolted on basically. So we can do this. At this point in time, this can do that. Heck, it might even have, with minor modification, you can increase the fuel tank just a little bit. You can literally land propulsively and then take off and land on Earth. This can do that. This can act as a escape pod from moon. It can be done. However, it will take time. I'm not sure whether you want to stay in it for 3 days. So that's another thing, but it can be done if you wanted to, with minor modifications, of course. Now everybody everywhere is like, okay, let's use Falcon series rocket to go to the moon. We can't do that. You have to understand, Falcon 9, basically Block 5, is very good, it's very cheap, and it's very slow. So the slow part simply means, even if you can put 22 tons to low Earth orbit, does not mean you can put 22 tons to moon, even if you want to basically use the slow approach. The only way you will be able to do that is basically you put one payload, basically 22-ton payload, and then have another pusher stage docked in space, and then using that pusher, basically you have to use 2 rocket launches to send your cargo. That is one way of doing it. Then, okay, let's say this does not have enough speed, delta V. How about Falcon Heavy? Again, to give you a rough context, rough one, this has, let's say, 5,000 km per hour when the second stage is deployed. This can go upwards of 7,000 km per hour with the second stage. So it does have tangibly much higher delta V. However, the weights and the volume is limited. So basically the carrying capacity of this is exactly as this. Even though they are saying a 60 ton, it cannot truly carry 60 ton. If you put 60 ton, it will crash under its own size. Basically, it's not wide enough to handle that kind of weight stably enough. So, and not to mention, Falcon Heavy flat out is not human rated. Falcon 9 is, Falcon Heavy is not. This is human rated, this is not. So can we use this rocket for our moon project? Absolutely. This will be very good for basically cargo mission. This will be the first way you can take care of. Basically, you can send rovers, you can send power systems, you can send habitats, and you can send like upwards of 100 of them, because they are as of now they are good enough that they can do multiple mission in 1 month. So we can pull this off. Like, you can just using this basically, and if you figure out how to do space docking with this sort of payloads, we can send hundreds of tons in one go. Basically, one transfer orbit, we're gonna have that. Basically, we're gonna launch multiple of this, then we're gonna send the pusher stage using this, and then directly land it on the moon. How the landing will happen, that will be a tricky issue, but it is doable with current technology. So the Falcon option is not as amazing as people think. How about SLS? Block 1 could do this? Yes, absolutely. Saturn V was basically inspiration for this. So it in principle can easily do it even with Block 1. It's very big, it's very fast, it can pull off that 3 days to the moon. Now, will it work? Maybe. Now, is it expensive? Yes, it's literally at least 4 times to 5 times more expensive than any other comparable option. The question becomes why? Because it's NASA. Basically, NASA, once they created space shuttle, they realized early on it was a bad design. Basically, they had bad fundamentals in that rocket. Basically, you should never keep people next to a rocket, you put on top of it. So if something goes wrong, you pull them out. They did not do that. Consequence, 2 accidents happened and lost upwards of 14 astronauts. So, and the project was cancelled before a replacement was done. So this time, and NASA continued to make that mistake. They are not like, okay, space shuttle was a bad design, let's just throw it away, let's try to try from scratch and let's figure something out. No, they did not do that, and they tried to build what we classify as constellation project. This was like first generation try to reclaim, reuse the assets that were created for space shuttle. Then that was cancelled after 5 to 6 years, I think, and a few $billion wasted on that. Then again, their SLS is the same thing. SLS is basically Constellation 2.0. They're like, let's retry to recover the assets from space shuttle, and I'm like, let space shuttle die. Let it die. Let it be like a good lesson. Like you learned from it. There were certain good aspects of it, specifically the engine that was used for space shuttle, the liquid fuel one, that was pretty good, and they are using it here. But let everything else go, man. Like just let it go. They want to use solid boosters on this. Why? I have no idea. It's like they can simply increase the diameter of the fuel tank and remove that, and instead of putting 4 engine, put 5 engine, and that's done. You don't need solid boosters. Solid booster is supposed to be like 5 block rather than 4 block from space shuttle, and it's still taking long. Basically everything about this is taking long, and I'm talking not in 10 years. Basically think of this, NASA went from 10 years to build from nothing to space, basically Saturn 5 from, and now it's like, yeah, we have been 20 years from space shuttle to trying to recreate something. So fate of this rocket as of now is very unknown, very dangerous, because even government is giving up. Like, we can't give you money like continuously 24/7 into freaking 10 years, and you're like, yeah, it's delayed. So at this point in time, government is not happy. And it's not like Obama government or Trump government. Like, nobody is happy. Like, at this point, this is not acceptable. You cannot keep saying like 15 years delayed, 20 years delayed. It's just not acceptable. So the fate of this, flat out, block 2 and 3 they did. Block 1, will that even happen? I do not know. And at this point in time, all the blame is going to Boeing, because Boeing is the contractor for this. So Boeing may end up in a scenario where Boeing has to take care of the basically rocket from its own pocket. Will it do with it? I do not know. So space SLS right now is very uncertain. Then we talk about the king of the bunch, basically master solution, BFR. Now, if it works, again, even if it delivers half of what it is claiming, it's more than good enough. Basically, all my discussion about rocket will end there. Like, if BFR works, done, go home. Only tricky part would be how you're gonna land BFR. Because here they are showing landing pads now. It is much trickier to land something this heavy. We haven't done something like that, because a regolith is completely different. And not to mention, when you're firing giant rocket basically on the surface, it's gonna displace it's gonna make a basic small crater just by the thrust of it. So that's an issue. And on top of that, because everything is on top, how you gonna unload it? Of course, there they are showing a crane, but again, that also becomes an issue. And that is why the recent design of BFR has a lot of basically small unpressurized volume area for cargo, basically from the bottom, so you can easily pull it out. Basically, they're supposed to use those places for basically rovers, science experiments and all that. So it is an issue. It is an issue in itself, where how you're gonna get the astronauts from top of the rocket to bottom, because you cannot have that what they showed in The Martian, where you have like a staircase from the center of the rocket. That's simply not gonna happen. So if this works, this solves all our issue. But will it work? I do not know. Will it ever happen? Simply because the biggest issue right now is cost is unknown. Early on, when they actually started to build it, is like cost simply went from 1 or 2 billion to 15 billion. So at this point in time, the only way SpaceX or Elon Musk can fund this is directly trying to make sure that Starlink project, basically their satellite internet, works, because Starlink is supposed to cost $10 billion and it's supposed to give profit of $30 billion. Now, if that happens, they can put that $20 billion into this project. So Starlink has to work for this to actually be completed, because as of now, flat out they are running low on money. Flat out they do not have enough funds to run this. So this was my presentation on basically rocket side of the equation of the moon mission. I hope you liked it, learned from it. In that case, please leave a like, and I would urge you to, if you didn't like it, don't worry about it, you can press dislike. I would urge you to press it twice to show me your extra disappointment. Leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.